Hey folks, one common problem with Python apps is how to share them with other people. And one common solution is to turn those apps into a web-based app. This is a good solution for things that have interactive components, like a data exploration dashboard. And in this video, I'm going to introduce one of the new Python libraries for writing such apps quickly, Streamlit. Streamlit is a library for, as the creators of it put it, turning data scripts into shareable web apps in minutes in pure Python. A Streamlit app can create an interactive web interface hosted on your own system or deployed remotely anywhere Python runs, including Streamlit's own hosting service. It also does not require you to know any HTML, CSS, JavaScript, or web hosting technology. It's pure Python on the developer's side. To get a better idea of how Streamlit works, let's take a look at a couple of examples. This example here is one of the first you'll encounter in Streamlit's own documentation. It's a simple demo that lets you work interactively with a visualization of a dataset. In this case, Uber pickups in Manhattan on a given day, presented by hour. The first thing worth noting about the way Streamlit works is that it uses a highly declarative paradigm. The objects you render in your visualization show up in the order you declare them in your code. In that sense, it's a little like a Jupyter notebook in that those are also evaluated top to bottom, and also in that they're re-executed from the top whenever you want to evaluate changes, whether to the code or by a user input. So from the top, here we title our page, and then we set up our data loading and formatting function. We're using pandas to load the data from a CSV fetched over the network, although we could use a local source too. And we present that to Streamlit as a data frame. We also use Streamlit's built-in data caching function to reduce the number of times that we have to load the data from its source. Now this part is a little important with Streamlit because every time the user interacts with the Streamlit page, the app has to be reloaded from the top. That's a side effect of Streamlit's design, and it's something worth keeping in mind when you write Streamlit apps. Caching the data saves us having to refetch it whenever we interact with the page. Another thing you'll need to bear in mind when using Streamlit, because of this design, is how to work with the state of components on the page, or any state that you want to generate and keep yourself. Let's consider this block of code here. What it does is place a checkbox on the page with a label, but it also inspects the state of the checkbox to see if any action needs to be taken. If we click this checkbox on the page is reloaded, the state of the checkbox is stored, and then the state of the checkbox then gets passed along to the program when it's reloaded. You'll notice that when we reveal the dataset, by the way, it's automatically presented in this nicely formatted grid that we can scroll through. We don't have to do any additional work to present that data attractively. It's done for us automatically. The next few instructions in the code create subheaders for the page, compute values, and plot data associated with those values. One of those plots is a bar chart to show the number of pickups per hour, and the other is an interactive map plotting the locations of the pickups. All of this we render in just a few lines. And the components we're using for this are all stock items that are included with Streamlit. That catalog of pre-made components, by the way, stretches into the many dozens in many different categories. In the event you need to womp together your own components, Streamlit has documentation for how to do that. Now, because of the way Streamlit handles persistent state, a lot of what you might have learned about state management from, say, web frameworks in Python doesn't really apply. This is probably the single biggest thing to keep in mind when using Streamlit for anything reasonably sophisticated, so I'm going to show you a specific example of what I mean. This Streamlit program takes input from a text box, displays it, and adds it to a list, which is also displayed. So for each input, the list keeps growing. Each input runs the script again from the top, too. So to track the state of the list across each run of the script, Streamlit provides us with an object named sessionState, which we can keep persistent state in. This code here checks to see if we have created a piece of persistent state, and if not, it initializes it with an empty list. Then, every time we have a user input, we append it to the list, and if the list is non-empty, we display it. Any persistent state across runs of your Streamlit program must be stored in sessionState to guarantee that it persists. It would be possible to write information out to a file and read it back in again, but sessionState allows us to keep this information in memory and live. Now, this kind of work does take some getting used to, and it will require some planning for how to want to model your app's behavior. But all of this is going to be offset by how convenient it is to create an interactive application overall with Streamlit. So if you want to create an interactive web-based front end to a data source and you want to use Python to do it front to back, give Streamlit a look. That's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.